Hi there and welcome to this tutorial. My plan for the next half an hour or so is to guide you through the end-to-end process of building a TM-Form ODA component from the ground up. So previous presentations we've taken a top-down view, we've shown the open digital architecture, the concept of components in Canvas, and had a top-down view to what is a component. My plan today is to actually start from the ground up, much more of a developer view. If I've got a piece of software, how do I take that piece of software and what packaging do I need to do to turn that into an ODA component that can then be automatically deployed onto this ODA canvas. All the work I'll be referring to is in the TM-Form Git repository under the TM-Form ODA area, and it's in the ODA CA docs component tutorial. And as I said, so the plan is to package, test and deploy an ODA component based on, we're using as a source piece of software one of the reference implementations of the open APIs, and we're just choosing this as a piece of software which offers an API. You could do this based on any existing piece of software in any language that could be packaged and deployed as a Docker image. If this is the first time you're hearing some of these concepts, I recommend first taking a look at this video, which is from the Digital Transformation World conference last year, where we did this top-down approach to what is an ODA component. If you're familiar with these things, then we'll carry on. So as I said, we're going to use as our source piece of software one of the reference implementations of the open APIs. If you go to the TM-Form Open API table, against every API, as well as there being a Swagger specification of the API and a design guide, there's also a reference implementation, and this is just a helpful resource to help people get going with these open APIs. And you can download the reference implementation from any one of the APIs. I've happened to choose the Product Catalog Management API, but we could be doing this tutorial on any one of these APIs. So go to this table, download the reference implementation, and what that gives you, it gives you a Node.js server implementation, so a bit of server-side JavaScript which implements the API and implements it on top of a Mongo database. And if you run these locally on your local machine, you can run it, deploy it, and it gives you this very nice Swagger doc version of the API, and you can go and browse through and exercise the different API resources and endpoints. There is a little bit of instruction on, if you want to test this locally using a local Mongo database, you have to have a Mongo database running on your local machine. If you want to run it locally, you need to put in this utils, Mongo utils JavaScript file. You need to change it so it's actually using a local host. So it's basically saying the URI for the Mongo database is exposed to this local host, and that's the standard port for a Mongo database. So you can test it locally if you want to test it and see how this works. It's a very, very simple thing to do, and when you test it, you npm install, npm start, and the API will appear at that URL. But we're not going to do that. We're going to go on to how would I take this piece of software, or any piece of software, what do I need to do to get it running in Kubernetes and to get it running then as an ODA component. So the first thing we do to run it within Kubernetes is we need, we'll have this Node.js service running as one Docker container. We're going to have Mongo database running as another Docker container. And so we have to link one to the other. So when I'm in my Node.js application, it needs to know how to access that Mongo database. And so I've got a piece of code here, so you need to put this into this utils, mongoutils.js file, replacing the existing connection helper. And what this is doing is telling you what URL you need to look at from the Node.js software to access the Mongo database. Now, because we're doing this as a component, and I could potentially deploy lots of instances of a component, that's part of the model, is you can have very easily deploy lots of components or even multiple instances of the same component onto an environment. So typically what you do when you package these things as Docker images is use environment variables so you can pass in some configuration information. So what I've got here is I've created an environment variable which is the release name, and this is something we're going to define later on, but basically when I pass it into it, I'll have a release name, so I could potentially have multiple Mongo databases running on the same environment, and then I'm forming my URI for my Mongo database, which is going to be the release name, then dash MongoDB. And in Kubernetes, this gets exposed by the Mongo database using a Kubernetes service. So I need to have that in my connection URL in the Node.js for it to work. And the other thing I'm going to do is, because I could potentially have multiple components running in the same environment, I don't want there to be any conflict of the path where they're exposing the API. So in our example, this product catalog management reference implementation exposes an API at this URL. So all the TMF APIs start with TMF API, then the name of the API, and then the major version. So this by default will expose the API at that URL. And what I want to do is I want to put the component name at the very base of that URL, so I can have then multiple instances of even I've had multiple instances of a product catalog API. They wouldn't cause any conflicts. So what I do is in the index file, I need to add this piece of code. So when I've got the Swagger doc, I basically want to, again, I'm going to use a environment variable to define a component name. So this is the name of the instance of the component, and I'm going to use that environment variable. And so I'm going to adjust the base path from the Swagger file, and I'm putting basically / in the component name onto the front of the base path. And the deployment also uses the Swagger UI, this nice Swagger user interface, and so I also need to adjust this piece of code. Is going to go into the Swagger sort of index.html file, and again it's going to replace and put in the component name into that URL string. So now I'll have my Node.js application able to access Mongo database, and it's going to expose the API at a URL where it's got the component instance, like the instance name, as part of the URL string. And then the final thing I have to do in the Node.js code is to actually expose something at the root of the API. So by default, when I use the Swagger tools to generate a reference implementation, all the different paths in the Swagger file will have a response. But actually at the root of the API, by default, you get no response at all from the generated code. And this has a couple of problems. One of them is, as a developer, when you deploy an API, you without looking in the documentation, it's very hard to see where the API is actually exposed, where the valid URL paths are to the API. But there's another technical problem. So when you deploy something in Kubernetes and use a Kubernetes ingress, the ingress actually will do a liveness test at the root of the API. So the ingress will say, I'm going to call this API at the root, and I expect a 200, like a HTTP 200 response. And if I don't get any response, I'll think that server is dead, and I won't try and route any traffic to it. So you find if you just deploy this reference implementation on its own, the ingress won't send any traffic to it. So we want to put something at the root of the API that gives some sensible response. The Kubernetes will do a liveness test, but also it's helpful for the developer that they can actually browse and discover what resources are available in an API. And in fact, in the TM-Form OpenAPI design standards, this TMF 630, there is a definition, a good definition, what they call a home resource, or an entry, sometimes called an entry point resource. And so what I've done is I've created, and it's in the tutorial code, I've created a little module that will generate this entry point resource again from the Swagger file. So all you need to do is add that entry point module into the utils folder, and then you integrate it by effectively using this app use as the very last part of the deployment of your API in the index.js file. And then the very final thing we do is, again, by default, when you have this reference implementation, it has this long, path to the actual API, but it puts the Swagger, the API docs, it puts the Swagger file, and it puts the user interface at these, at these resources from the root. And again, if I had lots of components running in the same environment, these would all be conflicting. They'd all be trying to put something at the same URL. So I want to remove that conflict. So what I do is I put these on the end of the URL path. And so effectively what I'm doing is I'm putting the API docs at the base path plus API docs, and the Swagger UI at the base path plus the word docs. And therefore, everything in the API is on the end of that URL stream. So when you do this, the last part up to this HTTP create server in your index.js file should have this thing where it's changing where the API docs and the docs are hosted, and it's creating this entry point. And if you do that, then the Node.js gives a much more compliant way of exposing this URL for the API. So that's the some small changes we make in the source code, and you could do the equivalent change in whatever source code you wanted to build into a component. So package it up so it's using environment variables to configure how that piece of software should work, and be considerate about if it's exposing an API, how do I make sure that API is a sensible one, which typically you want to put something as the base path, like the component instance name as the base path of the API, so then you're not going to get conflicts when you deploy many components in the same environment. So the next step, step 4, is to package. I want to package this Node.js piece of software as a Docker image. And so what I do is I create a Docker file with instructions to build that image. And I start this one because we're using Node as the programming language. I start it with the official Node Docker image. So the start of my Docker file says from Node, and then it'll download the official Node Docker image, and then we build from that. Clearly, if you're using different programming language, you would start from a reasonable image for that programming language. And then what I do is I want to copy the package.json file, which effectively has all the JavaScript packages that you used in that implementation. So I copy that, and then in my Docker file I say run npm install. So the image will be as lightweight as possible. It doesn't actually have all the libraries in the image. It's as lightweight as possible, and it will build and it'll run npm install to actually install those packages into the image. And then finally I want to copy the source code, which is called implementation. I copy the source code, and then because that Node.js application exposes the API on port 8080, I want to expose port 8080 from my Docker image to the outside world. And then finally I'm telling it what command to run, and the command to run is node index.js. So the complete Docker file is very simple. It looks like this. It says from node, copy the package, do an npm install, copy the source code of the implementation, expose port 8080, and then run this command. And then before we build this Docker file, I just want to create a Docker ignore file so that it doesn't attempt to copy the actual any node modules that I might have installed on my local machine. So this is just to make the Docker image as small as possible. To build the Docker image, there's a simple command you run, which is docker build, and then you need to give it a tag. And I'm putting this into my Docker repository in Docker Hub, and so I'm using Lester Thompson, which is my area in Docker Hub, and I've called it Product Catalog API version 0.1. And I'm also giving it a tag of the same thing but with the version latest. So you can give this an image multiple tags, so it has a version number, but someone can always get the latest image by saying latest. So that command will allow me to build that Docker file, and it'll overwrite any previous image because it's got this latest tag. And you then, because Kubernetes will download these container images directly from the source repository, so you then need to upload that Docker image into whatever Docker repository you're using. And I'm using the default Docker Hub, and I'm using my own account. So you have to log in, so do a Docker login where it'll ask you your credentials to log into the Docker Hub, and then I'm doing a push, so this gets pushed into this public repository. Now, as I said before, you could deploy this from any repository, and when we create the component envelope, the envelope will reference through to whichever repository you're using. So the idea is that the actual Docker images don't have to be public. We're making the component envelope, like the metadata, public, but the Docker images could be in a private repository. For the sake of this tutorial, I'm using the public Docker Hub repository. Right, so step 5 is to actually then create this component envelope. So far we've only actually been doing very standardized software processes around how to take a piece of software and make it suitable for packaging as a Docker image and then packaging it as a Docker image. So this is the first place where we're actually doing something quite specific to this TM-Form open digital architecture. And so we're going to create this component envelope. And people, if they've seen this previous presentation, will understand there's this picture of a component envelope, which basically says a component should be self-discoverable with all the metadata required to deploy and manage and interact with that component. So we're going to build this component envelope, and the metadata is going to have some standard Kubernetes resources as well as some TM-Form extensions. And there's a detailed breakdown of this in this ODA Component design guidelines. So you go to this URL, it'll show you all the description of all these different bits of metadata that we add. But this effectively is referencing the IG 1171 design guide, which actually introduced or defined the concept of an ODA component. So we're going to create this component envelope using Helm, and Helm is a package manager for Kubernetes, and it's you call the packages you create, you call them Helm charts. So to do this tutorial you need to have Helm installed on your local environment, and then to create a Helm chart the best way to do it is to use the command helm create, which will create a boilerplate chart. And if I do helm create, it will create a boilerplate chart which looks something like this. So I do helm create product catalog, it'll create some boilerplate code, which, as you can see, it creates a folder which has got the templates from a product catalog, and in that there'll be a charts, a templates, and then a chart.yaml and a value.yaml. And if I go through all of these in turn, so the chart.yaml, we don't really need to make any changes to this. This is just describing the chart itself, and so it says it has a certain version, it has the name, you can improve the description, but this is just very basic metadata about the chart itself. The values, this is where we can parameterize. If in our envelope we can parameterize the envelope and have almost like substituting values as a parameter and have them captured in a single place. And this also allows you, when you deploy a Helm chart, you can actually apply some almost like user or almost like runtime parameters into that Helm chart. So the values contain some sample parameters, and when you use them in a template, you basically put them in curly brackets. And if I look in our values file, we will define just a single parameter, because I'm trying to keep it very, very simple, and I've defined a value which is a component type, and I'm saying this is a product catalog component type. And so when I use that in the templates, you will see it'll have a component dot type, and if I use that, it'll replace it with this value here. Now the charts folder that it's created for you is actually initially is empty, and you can use this because the Helm is like a hierarchical model, so I can actually have a Helm chart within another Helm chart. And we could, we're not doing this simple tutorial, but we could use a standard Mongo database Helm chart within our chart. In fact, that would probably be the best way to do it in a more of a production component. Just for simplicity, I'm just going to create my Mongo database as a very, very simple sort of single deployment. But in reality, you would probably use an existing or the official Mongo database Helm chart, and you'd put it in this charts folder, and then it becomes almost like a subchart within our Helm chart. But for this example, I'm just trying to keep it as simple as possible, and so most of the work I'm doing is actually in the templates folder. And if you look inside the templates folder that's generated by this this command, Helm create product catalog, in the templates folder, it initially gives you some almost like starter templates. So it's saying it'll give you a starter template for deployment, HPA and ingress, a service count and a service. For what we need, we're actually going to create 2 deployments, and one of the deployments is for the Node.js container that implements the API, and the second one for the Mongo database. So the Mongo database runs as one microservice, the Node.js runs as a second microservice, and these are both created by Kubernetes using a deployment. So delete the existing template deployment YAML file they created, and we need to create 2 new templates. One is called deployment product catalog, and the other is called deployment MongoDB, and they look something like this. If I go back here, so the deployment template looks like this, and so this is the deployment of the product catalog API, and you can see this is all standard Kubernetes. It's a API version. It's in the apps API space. It's a deployment. You can see in the name we're going to use this template, and this is the release name. So when you actually do a Helm install, you give it a release name. So we're going to use that release name in front of this term product API, so that we could have multiple instances of this Helm chart or multiple instances of this component deployed at the same time. The component name, so this is the instance name of this component. So we're going to create the instance name by combining the release name and the component type. So if I did deployment of with the release name test, the release name test, and then the component type is what's in that values file, so it'll be product catalog. So then this deployment would be a deployment with the name test product catalog, and then I'm keeping it really simple. So I'm just saying this is one replica, and it's matching the label. So when the deployment creates the replica set and the pods, this is the name it's using, which is the same name here. And then I'm saying, and this deployment has one container, and this is what we defined earlier in the Docker file. So this is Lester Thomas product catalog API latest. So we're just going to deploy the latest version of that product catalog API container. And this, remember, we defined or we used some environment variables. Here I'm actually going to define those environment variables. So I'm saying in this template, I'm defining an environment variable called release name, which is the release name from Helm, and the component name, which is the name of the instance of this component, which I'm using the release name and the component type. Yep. And you can see then I'm using port, and it's port 8080, which is what was defined, what that was exposed in that Docker image. So I create this deployment API and a similar one for Mongo database. And you see this, it's really, really simple. Like in a production environment, you'd probably create a Helm chart with a, a load balance sort of, with failover and things like that for your Mongo database. But just to keep this very, very simple, I've just created a very, very simple deployment for a Mongo database. And as the container, I'm just using the default Mongo published image and the latest version of that. And so I've packaged up the deployments for the product catalog and for the Mongo database. The Mongo database requires a persistent volume, and so which is a different Kubernetes resource. So we create a persistent volume claim, and so again we use this in the Helm template. So I create a persistent volume claim Mongo database.yaml file, and it looks like this. So I'm basically saying I want a 5 gig storage, and I give it the metadata, I give it a name, and I'm labeling it as being part of this ODA component. And then we need to make the Mongo database available to the Node.js container, and you do that using a Kubernetes service. So I'm creating another template for a service for Mongo database, and this is just saying, for Kubernetes to create effectively the ability for my Node.js application to call via URL this service name. And again, I'm giving it the name Mongo database, and it's part of this component product catalog. And then finally, and because of this product catalog API I want to expose to the outside world, I create a service for the product catalog API. And you can see then I've got the service where I'm exposing it to the outside world using the release name product catalog API. And you see I'm exposing the port 8080 in the Docker image. I'm exposing to the outside world through this service. Yeah. So these are all the Kubernetes resources we have. So we have the product catalog API, we have the Mongo database's deployments, the Mongo database has a persistent volume claim, and then we have a service for the Mongo database and a service for the product catalog API. Now, so those are all the Kubernetes resources. The last thing is actually then to create this component metadata. Yeah, and this will be a very simple example because it's going to a component that only has a very simple core function, which has a single API. But what we do is we create the component metadata again as a Helm template. So we'll create a file called component product catalog.yaml. Get the actual. This is what it looks like. So the component product catalog.yaml. So this is where we've extended the Kubernetes model. So we've defined sort of a namespace oda.tnform.org, and we define this custom resource called a component. And again, I'm giving it a name, which is the release name and the component type. I label it, and then here's where I have the spec, and the spec is what we've defined in this the design guidelines for how you build a component. So in the spec, it has the important thing is it has a core function. And the core function is where you're saying these are the APIs I'm going to expose as my component. And you see I've got in my exposed APIs, there's a single API I'm going to expose, which is product catalog management component. I'm telling people that this is based on the TNForm product catalog Swagger definition. So at design time, someone can come and see ASIC that you are a product catalog, a standard product catalog API, and telling it where the implementation is, and the implementation is in the release name and then the term product catalog API. So that is the service that I created. And note that I can have as many instances of this product catalog as I want because each one is deployed using the release name. And then it's telling me the path to the actual API. And you remember I wanted the component instance name at the root of the API. So this template saying, the path where the API is exposed has those embedded in it. So again, I have as many instances of this API, and this metadata helps then a developer discover where the API is hosted. And I show where the actual API is, and I also show there's an optional thing where I can give a path to a developer UI, which is links to this Swagger UI. So that is the component, and it's a very, very simple component. So I haven't got any dependent APIs, I'm not publishing any events or not doing anything else. So I try to keep this tutorial as simple as possible. And then the very last thing is, because I used a few parameters, I just need in the values file, you saw that earlier in the values file, you just then have one value, which is I give it a value to this component type. So I've used component type multiple times in those different templates, and in the values is where I give the component type an actual value, and I'm calling it product catalog. Now, so we've created a Helm set of Helm templates. I should be able to test that, and a good way to test it in Helm is you can actually run this command where Helm will just create a template for you. We'll go through all the templates and create a standard YAML document for you. So if I run this command, let me copy and paste it. Then Helm is going to go through and it's going to put the result of going through all those templates into this file called test instance components. I gave it the name or release name test instance component.yaml. Now if I go and have a look at what's just been generated, it looks like this. And so you can see it's created this effectively a YAML manifest file, and it's saying the source template was that just as a comment, and then you see it's actually put in those parameters. So because I call this release test, then it's the persistent volume claim is called test MongoDB PV claim. It's part of the component test product catalog. The service it's got the same sort of naming. So you notice it's used all those different parameters to create a standard set of Kubernetes resources. Notice as part of the standard is we give everything a label, which saying has an ODA inform.org component name label. So all these resources at runtime will belong to this test product catalog component. So, and one of the nice things with this component model is you create lots of these different individual resources in Kubernetes, but they all have like a parent-child relationship back to this test product catalog. So these are the standard Kubernetes resources, and then at the end, this is the extension that we've created, where we define this ODA component resource in Kubernetes, and this is the thing which is going to help us discover, the metadata about that component, which in our case the metadata is very simple. It's saying it has a single exposed API. So this looks correct, but what we've actually got is something that looks correct. We can test whether it is correct, and so there is a CTK, a compliance test kit that we can run against this component, and it'll tell us whether or not the component is compliant. And again, this is the link to the component CTK, and actually I've got it locally. If I just go up one, So here's the folder for my component CTK, and again the component CTK is just a node application that at the moment it runs a set of static tests against that component. So all I need to do is I need to say npm start, and I need to give the name of that component YAML file we created from that Helm chart. So I need to say I need to go back to the same folder, and it was called test. Yeah, so I say npm start, and I need to give it the name of the sort of manifest file for that component, and this should run a set of at the moment it's just running a set of static compliance tests, and these compliance tests match what's in the design guidelines for component. So it's doing some very basic file tests that it is a valid name for component, because we tend to use this as a standard naming convention for components. It's a valid YAML document, and then it's testing the metadata that we added. So it has a document of kind component, which has an API version, metadata, labels, and a spec, and expecting the spec to have these standard resources. Yeah, and then finally it's checking the step 2 is it's checking that any standard Kubernetes resources are labeled, so they're showing that they belong to that component. And you see there were, the deployments, the persistent volume claim, the services, they were all correctly labeled as belonging to that component. So this has magically passed the CTK, and so then the last step for us is to actually then try and deploy it into our Open Digital Lab environment. So if I go through this, so to find the Open Digital Lab environment, it is at this URL rke.tnform.org. You could deploy this on any Kubernetes environment which has this canvas deployed already, and all you need to do to get this is you need to set up your local kube control command so that it's using the config for this Rancher environment. And to do that, you choose the actual cluster we're using. So I'm using this candidate stage 1 cluster, and then you look at this and it says a kube config file. This is the config file which needs to go at that location, and that configures kube control to point to this Open Digital Lab Kubernetes environment. So I copied that, I pasted it into my kube config file, which we will find if I show hidden files. It's here. So I take that and I paste it in here. And now my kube control should be configured to run against this Open Digital Lab environment. So what I will do is I can test that it's actually working by just saying, kubectl get all, and I need to give it the namespace. Like by default we only have access to this components namespace, and so I need to go kubectl get all namespace components, and it should just show me whatever is deployed in that namespace. It's just showing that kube control is correctly configured. You see there's nothing deployed at the moment. And then what I can do is, I normally do this, I set my context so it always uses the namespace components, so I don't have to put that at the end of my command every time. So now I'm in the namespace components for everything. And then I need to go and do a Helm install. I don't need namespace components for that product catalog. And that should deploy that product catalog component. So I need to go back to the white space. So this is where I created my Helm chart. It's in this product catalog. So I need to run the command Helm install. You give it the release name, which I'm calling test, but you give it any name you want to. Helm install product catalog, and that should actually go and create the deploy that instance of my product catalog component. And then just to see that the data, I can actually do a query. Because we've extended Kubernetes, I can do a kubectl get even on our custom resources. So kubectl get components, and you can see that it's recognizing that there is a test product catalog instance of a component deployed. At the moment it's not showing me where it's exposing the APIs, because it's actually going through the process of deploying the Mongo database, the product catalog API, those two services, and it's going to, in addition, it's going to configure whatever ingress or API gateway is set up in my canvas to expose my API, and when it does that, it should update the component custom resource with those details. And this is what we when we talk about the component being, or the metadata being discoverable, is I can look at the runtime environment, and it only takes a few seconds, and you see now it's actually exposed the API. And you remember this is the path of the API. We added the name for that component instance onto it, and it's exposed actually at this IP address. So here is the URL where I can go and access that API. And remember, this is pointing at the root, or the home page, or the entry point of the API. So I should get a response, and here it is. You can see this is the home page resource for the API, which is listing the different operations that I could do against the API. So I could list a catalog by doing a get that URL, or I can post to create a catalog. And as well as the actual API itself, it's showing me where there's a developer UI. This developer UI is at that URL, and this should take me to like this Swagger docs for that API. So again, I get the nice Swagger user interface, and it's got the correct path to that API, and I could then go and browse to any of the API endpoints by using the Swagger tools. And that is it. That was the process to create or to package up a piece of software as an ODA component. And we've packaged it up, we've tested it using the CDK, and we've deployed it in this Open Digital Lab environment. And one of the very nice things to do is I can actually then uninstall it, and it'll, because of the parent-child relationship, it'll uninstall all the different parts of that component as one unit. Okay, hopefully that was helpful, and please leave any comments below if you have any more further questions.